Beside what's written in the agenda, it's not Luca from Digital Globe which starts, it's actually me giving a short introduction into day 2 of Wherecamp Berlin. And my name is Nowak. I'm one of the organizers of Wherecamp Berlin, and I want to give a quick overview about the last sessions, also a little bit scoping into what's coming in the next days and also next year. Yeah, it would be great if you all take a seat, if you could, because I would also like to start with a little analog survey. Just hands up, please. Who was there yesterday? Oh, great. Who actually visited Wherecamp last year? Okay, significant less hands. And is there anyone who visited all of the Wherecamp Berlin sessions already? Okay. Okay, I see. So I think it's actually then it makes a lot of sense. It goes a little bit the history of Wherecamp Berlin. As written here, the whole thing started in 2011. Actually, it was not even Wherecamp Berlin at that time, it was Wherecamp EU. So for those who visit yesterday's talk from Gary Gale, What 3 Words, he's also the founder of Wherecamp EU. And the 2011 session actually started here in Berlin. For those who know, who had a Geo beer yesterday evening, they had one too at that session. If you could see, that is Prater in Prenzlauer Berg. And yeah, that was a really nice end of that session, as far as I remember. I don't remember that much of that time, sorry. Yeah, so this is actually where all of this started here in Berlin. Jumping forward to 2012, what happened in between? Roland from Boyd University and Philip Kandal from Telenav and myself, we sat together, I think it was in San Francisco at that time, and we all visited Wherecamp EU 2011, and we thought it would actually be super cool to have a similar thing also running here in Berlin. We met at that time, I think it was Where 2.0, which happened in April, as far as I remember. And who knows, Where 2.0, long time ago, there was also a Wherecamp at that time. So there was a traditional bar camp next to Where 2.0. Where 2.0 was a geo conference in San Francisco, very much dedicated to professional work. The tickets were extremely expensive, as far as I remember, a 4-digit number. And yeah, so the Wherecamp San Francisco was really tailored to people who were more into tech. They paid nothing, really agile, and yeah, we liked that setup a lot, and we would like to transport it also here to Berlin. And so we started with a session at 2012, and as you can see, that is actually the visitors list we have at that time, and all of these spots marked people from different countries. Obviously, we had a lot of European people, but you also could see some people from, I think, somewhere in the Mediterranean Sea, some people from Japan, the Philippines, and the US, and so on. And the hashtag that marked in there was, you know, some hot topics I remembered we took as some key topics, because every Wherecamp usually have a few key topics around. At that time, the one I remember was actually NFC. It is not that much geo-enabled technology, I have to admit, but it was some kind of trending thing, and many people believed that it was also a changer in interacting with devices and bridging analog gap, bringing into the digital world. And yeah, it was quite interesting. Why is there a number 1? Yeah, because the Berlin session 2012 happened in summer, and due to the great success, we thought it would be cool to have also a second edition. We called it Campfire Edition. It was in Christmas, and yeah, we had actually good support also from the that time Skobler, now Telenav team, who brought great designers and made this nice logo and poster. At that time, the second edition was really hot about data visualization. I think it's a topic that still is hot. We had talks from Car2DB and also from Mapbox, and you can see how do you present your data on top of a map with a really nice map as a canvas. That is all still trending topics, so it's lasting. Yeah, 2013, there was actually kind of let's say, tech map, if you would say like this, that collected some of the phrases and some of the impressions from the Wherecamp. And you could see that was the 2013 edition. At that time, we had only one edition. But it was also, I think we had the same amount of visitors, also roughly 150 to 200 people. And at that time, 3D MIPS was trending. Why? C3 company, a Saab venture who created the 3D maps, was actually acquired by Apple and was done also available in iPhone and iPad. And I think also here had a 3D map offering at that time based on this more or less same technology. It was quite cool to see how that turns out also on many devices. Yeah, the last year edition, 2014, I think similar to this event, we had also an app, and also like this, we had an initial version of indoor mapping. As you could see, the hashtag indoor, I think we find it also this year again is still a trending topic. Especially I think Boyd as a campus is a very good example of how difficult it is to find certain places in a vast area. I mean, I remember my first time here, I think it took me 15 minutes to get actually to the right building. I'm not saying that I'm somehow from the geo industry. And yeah, so you could see the way how it's illustrated with the certain icons. That was the first version. I think Jolie and also others demonstrated the last efforts from indoor, and you could see the vast improvement that actually these offerings had, also including now real indoor routing, which at that time was actually not working, I have to admit. Yeah, so jumping forward to this event, obviously it's not gone yet. I think we heard already some really good talks. I mean, personally, I really like also the panel discussion. I think we jumped to, thanks to Roland, I think to every topic that's now trending. And but what's actually in my mind still is that also traditional players shifting away from classical map making into actual data processing. So you can see they are now folding exabytes of data in real time, and they see this also as their biggest challenge. So I think what is pretty clear is also that we're seeing other players from maybe non-GeoIT related domains jumping into market. You could see, for example, SAP going into the geo market. You could see Oracle going there. So these are all companies who have experience with processing really, really big chunks of data. And I think that's also no new frontier. But also happy afterwards to hear your opinions about what's trending. Yeah, so what is next? So one thing that I'm also doing next to Wherecamp is a spin-off which started in 2013. It's called Geomonday. We had this year, it's I think the edition with the most amount of events. It's 7th of December. There is the 4th edition. Last one was actually also pretty cool. We had, usually we're in Berlin. We had Mobile Suite, so it's somehow our headquarter nowadays. But the last event was in Potsdam, and we had the pleasure to have a live drone event. So for everybody who's interested, just visit geomonday.org and visit the blog there. You could see some live videos. I think there was some professor from Brandenburg who made real-time 3D modeling using stereoscopic drone imagery. So I think he made a 2-minute round flight on top of a building which was close, and started an application processing for roughly 2 hours, and then you could see a 3D model of this one, fully textured. It was quite impressive, and you can see everything there, so pictures and videos. Yeah, so I would be happy if you also afterwards, 7th of December, joining there. We have still some places left. We have already some good speakers. Topic is this time experience your places. It's mainly about aggregating places, harmonizing places data, and processing them into applications. We have speakers there from Yelp. We have speakers there from startups. So it's, I think, as always, a quite good mix. Yeah, and none but the less, we said it also yesterday, there is a new association in the process of being found. You can see it under the domain. It's GeoIT.org. So for everyone who is interested, please also follow up and sign up there. You know, nothing to pay, anything. It's just that we're collecting interest because as it's in the process of being found, we want to see, okay, what are the members we're seeing, private, corporate, governmental members, and what actually the way we can offer networking capabilities and so on. So everybody is heavily invited to do so. All right, so that's basically just the opening. I would then also invite Luca from Digital Globe to continue with the first talk. So a little applause for Luca, maybe.
Good morning. I have the tough challenge to keep you awake in this first call after the social night last night. Let's see if I can succeed. I'm Luca. I'm from Digital Globe. At Digital Globe, we take very high-resolution satellite images of the Earth, like that one, which is Berlin, actually. I would like to start asking you to think for a second, how did you get here yesterday or today, for the matter? I'm sure pretty much most of you who didn't come with a taxi had a phone with a map on it. And perhaps some of you have even brought up the satellite view to understand more of the context of where we are. If there is a park nearby, you can go for a run later. Where's the street, and if there's car parking, and so on. This is what I would like to talk about today, and I would like to talk about how satellite images are at the foundation of every map. To do so, I would like to tell you a story. Apologies if you've heard already. In fact, am I going to ask it? Have you ever seen this image before? Can you raise your hand if you have? One? Really? Two? Okay, pretty good. Well, actually, I love this story. This is the Great Survey of India. This story takes place 200 years ago. I hope it's cool to tell this story actually nowadays, but I think it is. British surveyor had mapped the whole of Britain, and now they wanted a bit of a higher challenge, so they thought to do the same in India. This is what they came up with, and they thought it was going to take them 5 to 6 years to do that. Well, it actually took them more than 60, and they lost hundreds of lives to diseases and I guess people aging as well at the time. Why did it take them so long? The reason being is because they put so much emphasis in accuracy. They already knew that the map needed to be very accurate to be meaningful. That survey ended up to be so accurate that through triangulation and calculations that I'm not going to bother you with, they managed to measure the curvature of the Earth, an arc of longitude. And therefore, they were able to prove Galileo's theory, although somebody still thinks otherwise, and I don't know whether that is real or not. But moving on, how did they do it? They started with a baseline of 7 miles, which they thought to measure with 100 chain foots. They took them 40 days to measure just that baseline because they did that measurement in so many different conditions, measuring temperature, humidity, and so on. They did it so well that it took them 40 days. Now, the story to me is already quite fascinating. Here's where it gets really, really cool. As they were doing the survey, they went up north, and they were close to the border, and they could see the Himalaya mountains. So I think they were really into this measuring thing, so they thought, let's measure the Himalaya mountains as well. Little problem is that the people from Nepal didn't let them in because they thought they were going to take over. So they thought to establish a number of observation points along the border we're talking about 100 miles away or more from the actual mountain position. And they thought to measure the mountains from there. It took them 10 years. Needless to say, 2 years were just about calculations. And at the end, they measured the highest peak, which they named after one of the previous lead of that expedition, Sir Everest. And they got to that number there, 29,000 foot. If you are from the continent, as I am, that number means nothing to you. But it's important I tell the story this way, because when they got to that number, they thought, well, nobody's going to believe that the mountain is exactly 29,000 foot. So what are we going to do? They sat together around the table, I suppose. I wish I could be there to see it. And they thought, okay, you know what? We're going to say a different story. We're going to say that the mountain is 29,000 foot plus 2. Really? They thought that number was more plausible. Fair enough. Now, today, with modern instrument and everything, we know that actually the Everest is 29,000 foot 29. So they were not far off if you think that they were doing that from such a distance. To me, this story is fascinating because as an engineer, the effort and the extent they went to get an accurate measurement, it's inspiring. But also it tells me that a map, they already understood 200 years ago that a map needed to be accurate to be meaningful. And the same belief we share in Digital Globe as we take high-resolution images of the Earth. Now, how does that translate? How the accuracy concept translate into satellite images? Let me try to explain it to you. When you take a satellite images, each point on the satellite, on the image, doesn't necessarily match with the actual position on the Earth. That error is called the accuracy error and is measured statistically with a circular error at 90%. That means that if we take 100 measurements of that roundabout there, the center of that roundabout, the statue in there, could appear anywhere within a circle. If the circle is 100 meters, so if the accuracy is 100 meters, it means that that center can be anywhere within that circle, which is pretty poor, although that is the accuracy that some of the small sat should. CubeSat, they do slightly better. They do around 50 meters. Landsat is pretty good for what it is. It's 12 meters. Our satellite do much better than that. They shoot well within 5 meters. And that is really important when we look at mapping with a satellite image underneath. And I hope I can explain this with this series of pictures. This is, again, Berlin. And what I've done is, in a very trivial way, I've drawn a road vector, if you want. Yeah, no, I've used paint, so apologies, it doesn't look really cool, but it shows the purpose. So I've taken a picture that we had, overlay the road layer, and then I've replaced that picture with a picture that we have got later, and later, and later, and later. And what you see is that even if we take new pictures, the overlap between the road vector and the picture itself, it's still really good over time, which is very important because that means that you can build your map and then keep updating the satellite picture, getting more fresh pictures every time, and you don't have to adjust everything again. So it shouldn't surprise at this point that our satellite images have been used in, and are used in most of the mapping apps that you do, use. So perhaps you haven't heard about Digital Globe before, but I'm pretty sure you've seen our pictures before. So accuracy is very important when we talk about mapping. There's another thing which is important, which is the way the map looks. From a satellite point of view, making a map that looks a satellite picture that looks good is challenging, especially when you operate a high resolution. High resolution here means 30 centimeters or 50 centimeters. This is what our satellites shoot. So the footprint on the ground is not extremely large. And as you take more images throughout the year, this is what you end up with. You end up with images that look slightly different in color because they have different seasonality. The atmospheric correction is slightly different because one day it's a bit more hazy, one day is less. That is all right, but it doesn't look too appealing from a user point of view. And we knew that, so we have put a lot of effort into making a mosaic where each pixel is balanced in color with the neighboring picture. So we have therefore created a country scale seamless mosaic, which we call Vivid, and that's how it look. We've done that for many states in the world, actually. US is up next. Well, it's actually being produced at the moment, so it's going to be uploaded. China is next, and we have all of Europe, and we're going to refresh the content very soon. So where are we today? I mean, we have all this content. We have done this beautiful mosaic, and we have so many new players coming into the geospatial industry. And I'm not going to use big data, although I've just done it, so I had to reward it as data abundance. Hope you don't mind. But the point is, there's so much information, which to us at Digital Globe poses two challenges. The first one is delivering it. How do we empower developers, map makers, app makers to create beautiful apps using our content? To tackle that challenge, we have created our own Maps API. With Maps API, we provide two base map layers, which I will explain in a second, together with the OpenStreetMap road vectors and Mapbox terrain data. The two base maps you can choose from are the Vivid one, which I've explained, and the other one is a more up-to-date content, which is not necessarily mosaiced at a country scale level. With more up-to-date content, you can also have metadata, so you know when the satellite image has been taken, and that might be a useful and valuable information. The other challenge now, the data size. We have quite a lot of data. How much is that? We are around 70, well, our archive was a couple of years ago, more than 70 petabyte, and that's quite a big number. In fact, we want to overtake Facebook, so we're going to send a new satellite in orbit next year. We're really taking this seriously. So we have so much data into our archive. We've been in this sector for 15 years, and every year we are imaging the world at very high resolution. Guess how much power, how much information there is in those images that is not necessarily really exploited. How do we unlock that power? How we enable people to extract the information that they want over a time series, for example? We have created a platform which we are pretty proud about. It's called Geospatial Big Data, again, GBD. The concept of this platform is it's kind of simple. We put all our archive, everything we have ever taken, on the cloud. You can access the platform through APIs. You can access the archive, but also our image processing algorithm. These are things like atmospheric compensation, auto-rectification, car counting, road detection, building footprint extraction, any algorithm that we have done. In fact, you can also access our partners' algorithm, like Envy. Do you have your own algorithm for counting windows in a building? Very good. Package it, put it on the Geospatial Big Data platform, and you can use it for yourself, or you can even share it. You can share it with third parties, so if somebody else uses it, then we would recognize you some revenue for that. Do we have a gap in coverage in a certain place where you need a really up-to-date image? You send a drone, you take the image, you put it on the platform. You put everything on the cloud, and then you create a workflow to extract just what you really need, which is the information, okay? This, to us, is a fertile field. It's a fertile field for a developer to create new applications, to develop new products, to develop new answers to questions that we haven't thought about, because guess what? We don't have all the developers of the world, and we don't know all the possible use cases. We want to empower people to do that, and this is the right platform for that. I'll give you a quick few examples. With a satellite image, when you take a multispectral image, which we do, you can understand a lot about the territory that you're looking at. You can understand soil, different trees, man-made structure like concrete, asphalt parking, and so on. You can see water, so you can, for example, think of counting how many swimming pools there are in Berlin, if people there having one. You can look at rooftop and look at the material on the rooftop. Do you want to know how many solar panels there are in Berlin? Well, I don't know, but I don't know. Is there sun here in Berlin at all? Okay, good. So there might be a few, but if you're interested to know the answer, Geospatial Big Data is the right platform to extract that information. You can create 3D model using stereo images, so images taken at a slightly different angle, not necessarily on the same day. That's called fortuitous stereo. And that is extremely high resolution because it's done with 50 centimeter or 30 centimeter images. So that is like a DTM, DSM, whatever, at an extremely high sampling rate. I love this example particularly. There is a company in the US who is looking at macroeconomic trends by just counting cars. Now, what they do is they count cars outside the manufacturing sites, and based on how that changes over time, and they do that at a scale over the whole world, they forecast the demand, the offer, the pricing, and so on. In fact, they've actually taken this a step forward, and now they're looking at retail stores. They can tell you if IKEA, or Lidl for the matter, is doing well by just counting how many cars there are out there, which is trivial to me, but nobody ever thought about it in Digital Globe. Now, imagine you are one of those retailer stores. Say you are IKEA, and you want to open a new branch in a place that you don't really know. How do you decide where to put it? Well, perhaps you want to do a bit of like geospatial analytics, geospatial understanding, intelligence, we can call it. Perhaps you want to look at a neighborhood, and you want to see if it's wealthy or not. Perhaps it's important to you if the houses have a garden, how many cars they have in the driveway, what's the square footage of the house. Perhaps all of these information are important to profile your customer and the area. In fact, you want to do that at the whole scale of the village where you're looking at. And perhaps you want to see changes over time. Where are new stores opening? Which area of the city is booming? Which one is declining? You probably want to know all of that. Well, you can do that. So finally, you can take a decision which is a bit like data-driven and not necessarily a finger in the air. Another thing that the geospatial big data empower you to use, it's something we are pretty proud of, is our crowdsourcing platform. That is called TomNode. It's an extremely simple website. I really invite anybody who's interested to contribute to the world causes to have a go at it. It just proposes you an image and says, is this a house? Yes or no. Is this a car? Yes or no. It's that simple. A 5-year-old person can use that. That crowdsourcing portal has been pretty famous for one of our most, I would say, interesting campaign, although it was not very successful. The search of the Malaysian flight, the MH370, I think. Well, there was a classic example of the needle in the haystack. We couldn't find the plane, of course. It was such a big place where we were looking at. But nevertheless, we had 8 million users trying to tag a number of satellite pictures. Some of those users are even famous, and some of them even thought they had found it. Well, Carney, I would think back about that. Anyway, how does the crowd help us? The crowd helps us a lot because it can improve our automatic algorithm and enhance the accuracy, can verify a lot of things, and can make things happen in a blink of an eye. And a mapping example is suitable for this context, I think. Despite most of the world as we know it has been mapped, there are many places that are not. And we understood that when we did a campaign in Africa trying to defeat polio. So there are people who are bringing vaccination to villages, but they don't know how much they need to bring. How do you solve that question? You look at a map. But what if a village is not on the map? And there are many like those. So this is a village in Guinea, that was pretty much not on the map. The cool thing is that when you reveal the satellite picture, you understand the truth, which is that is how big their village is. It's like 80,000 people that almost didn't exist from a mapping perspective. So we throw that image to a bunch of volunteers, and literally overnight, they mapped every footprint, every road of the village. They put the village on the map in a night time, which is a pretty good achievement if you think where we started. It took 60 plus years to map part of India, not even everything. And now, thanks to satellite images, we can do that extremely quickly with image processing algorithm, using the crowd, and so on. In fact, satellite pictures have empowered us to do even more. They've empowered us to understand the world we live in, to understand correlation between different places, to understand trends at a global scale. Okay? And this is not even 200 years old idea. it's more than 2,000 years old idea. And yet, I think we're just scratching the surface. Thank you very much.
Okay, maybe not. Okay, thanks, Luca, for the presentation. Really nice. Do we have some questions, maybe, regarding it? Nothing. Okay, cool. One question here.
Did you hear the question? Shall I repeat it? How does the last slide relate to OpenStreetMap? It relates in the sense that OpenStreetMap relies on volunteers. If you don't have volunteers in Africa, you're not going to map a village. And not necessarily you have the satellite pictures for every place. In this case, we had to go and take that shot because we didn't have that in our archive. And we used the volunteers in OpenStreetMap, I think, to map that place. So that's how, that's the link between that map and OpenStreetMap, I suppose. Does that answer your question? Okay, okay.
There's one more.
Go for it. That's a very good question. Did you all hear that? That was pretty loud. How do we decide where to take the shot from the satellite? There's a number of parameters. It's an algorithm that uses information like cloud cover, for example. It doesn't make sense to take a shot over clouds. However, having said that, we have a pretty good, our satellites, which are fairly big, are 15 meters long. They have a pretty great accuracy and they can point even in small places in between the cloud. That was the case in Nepal after the earthquake. The shot was pretty cloudy, but there was a hole just above Kathmandu. And we pointed the satellite there and we managed to get a good shot. So cloud cover is one. Clearly there are things like refresh programs that we have or customer demand. So based on where the satellite is passing and a number of parameters of how is the satellite going to be pointed, because it really doesn't take any sense to take an image with, I don't know, 10 degrees off the horizon. We score places and then we optimize the collection plan for the orbit. So the satellite passes on the Earth, talks to a central station that says, these are the places to take a shot for, takes a shot, send it to the central station. Within 2 hours, you have the image, pretty much.
More questions? Okay, really cool. Thanks again. Applause. So next speaker is Alexei from Locomizer? Locom? Yeah, okay.
Hi everybody, thank you very much organizer for inviting. It's a great pleasure to be here. So my name is Alexei Folikov. I'm a co-founder of Locomizer. It's an early stage startup from London. Before founding Locomizer, I used to be a scientist. I used to study spatial behavior and life system at the level of cells. And you'll see how it's connected to Locomizer story later on during the talk. So today I'm going to tell you about what we do at Locomizer and what I think could be interesting to a broader geospatial community. What we are doing is we look at billions of geolocated points linked to users, which is scattered across different verticals. It could be geodata from smartphones, mobile applications, mobile search, social media geotag, like geotag tweets, for example, data from mobile telecoms, and we take a closer look at what all these individual histories, which create a great opportunity for understanding the next generation of consumers. we're looking at the insights which are hidden behind this raw lat long and timestamps. But the thing is currently the big flaw in our understanding of location data and how we interpret all this spatial information linked to humans. I mean, just to give you a few examples of what can go wrong when you take the current very primitive way of looking at things. For example, if you look at these pictures, green pinpoints at points where users spend the time, and it's eating, drinking places, and the red, it's cinemas. So it's all in London. For example, if you look at this middle picture, so what currently marketers, for example, do, they collect all cinema lovers only around the cinemas. So you can see that in this particular case, if the user, for example, spend the time in eating, drinking places around the cinema at some distance, and never showed up in the cinema on a smartphone, so it means this person will be eliminated from the analysis. So he won't be considered as a cinema lover. But what if this person never opened the smartphone in the cinema for some reason, but then after or before the cinema he goes to eat or drink coffee at some places? And also, if you look at this picture, for example, if you go to the cinema and you will be in this box, why? It could be that you're actually not a cinema lover in the first place because you're simply close to the cinemas because they're eating, drinking places which you prefer close to them. And again, the third picture shows that we don't really take into account how the places are distributed around in space. For example, here, so if you visit all places in the small area which are just eating, drinking, nothing around, so you'll be probably the same eating, drinking lover as this one, but there's a clear difference which shows that you are more interested in eating, drinking than here. So all this shows that the really simplistic view on the location behavior of consumers, which in the first place, in the first instance, is really rational. So we consider this as a rational approach to location. But in reality, we think that what we have on the map and how we look at the location points on the map, it really reflects the world we see. But in fact, so each of us, they have a different perception of what is on the map. And just to give you a few examples how it could potentially look like, there's some tests which scientists do on spatial perception. And one of the tests is just to understand how people look at global versus local, or forest for the trees. So if you look at this picture, then you ask to find out which one is most similar, this one or this one. So the people with a global perception, they will choose this one, because the global order of things is similar between this and this one. But people with more local perception, they will choose this one because the small details are similar, even though the global order is different. Going further, for example, another a set of experiments scientists do, they look at how you perceive the space based on the context. So you can see that this ball and this ball, they perceive differently because the context around this and this is changed. So it shows, and it confirmed by scientific data, that what we see in our heads is not what we have on the map. And the same is true for the distances. The distances which you perceive in space and time, they also depend on your emotions and your motivational status and so on. So, so you can see that there's some kind of paradox. So currently what we do with the location data, we look at it from the rational perspective, from the kind of map-based, which is common for everybody. But then we make a decision on an assumption of human behavior based on that. But the thing is, it's a proven fact that the perception is not, and the distortion of space is not that great when the person is unmotivated, when the spatial object or places are irrelevant to a person, or a person is unhappy. So the thing is, all the marketers at the moment, they are profiling people based on this assumption that we are not motivated, we are not, everything around us is not non-relevant. So, so sure, there must be a solution. There must be a solution, and the solution probably lies in our brain. How the brain that understands the space and how it transforms the spatial data into relevant and personalized pictures. So there must be a map somehow. And thankfully, in 2014, there was a Nobel Prize for its so-called GPS system in the brain, where the scientists found the region, really like an ancient part of the brain, anterior cortex, where the spatial signals are transformed in some kind of a map. But in reality, we found out that there's no actually a map. There's no map in the brain which we can say that this is a representation of a personal spatial experiences. So on the right is actually what we have. This is what our brain collects about space and time. So it's hexagonal pattern of firing where neurons fire. If you, for example, imagine this is a room, so or a square. So when you'll be walking around, so the firing will have a precise order. And the space between this firing and the arrangement between them will depend on geography and on your experience. So if nothing is relevant for you, so it will be, for example, this representation. But if something is more relevant to you, and so there will be distortion in this map. So it's not one-to-one correspondence. So there must be some kind of a code which translates all the spatial data we have on the map into what we have in the brain, how we store it and memorize and then use for for making the next move. So how make sense of all of this, all this understanding that analytics behind spatial data is wrong, and actually the brain doesn't give us the clear answer. So we look at this, some insights which we can get from nature, and more specifically, for example, from cell behavior. So these are just a few examples of several types of cells which we found in our bodies, which just move freely on a dish. So you can see different cell types move differently. They have different speed, they have a different persistence. Some of them just move more randomly, some of them just really champions. They don't turn sideways. So, but you can say that, this is just the movement of one cell, and I can say that they're moving. That there's no map here. They don't have representation of space, surely. But the thing is, what's interesting when you try to look at, for example, the development of organisms. So these cell types, they form really nice and organized patterns. For example, this is the embryo of zebrafish, and you can see the stripy pattern in the hindbrain. So if you take a closer look, you'll see this really segregated, two types of segregated tissues, green and red. So they'll never mix. The thing is, if you take these cells and these cells together and mix them randomly, so what you'll see, what will happen in a dish with time, that these cells, even though you force them to mix together, they finally get away from each other. They segregate. But surely there's no instructions. You can't find instruction in, sorry about that. You can't find instruction in an organism which gives, for example, green cells. It tells green cells go away from red one, and vice versa. So, but for some reason, even without the map, this pattern can be formed nicely and precisely. So we think that we found a solution of how the cells actually find a way in space and time without the map, using some statistical physical approaches, for example, taken from phase transitions, where all location data is actually not looked at the perspective of the distances, but it looks at the perspective of affinities, so or interaction. So the cells form actually the precise patterns because they have some intrinsic mechanism to detect the affinities between themselves and environment. So we take this advantage in our platform, which Locomizer built, and we translate it to the humans. And so what we do as a business, so we take location data, which I've described before on people, and create the interest profile which describe affinities of a user to different locations. So it's not distances, it's actually the affinities or attraction scores which link us to different environmental factors. What we do also next, we aggregate these profiles and create the place profiles, which will tell you how they work. So in a nutshell, we create the 360 degrees view of a customers based on how customer is connected to the environmental cues. So coming back to these three pictures, so if you look, for example, again in the center one, so even though if you, based on our algorithm of translating location data into the affinity scores, so even if you are a visitor of eating drinking places, you'll get the interest score to eating drinking, but you also get the, some affinity to the cinema, so we can capture this. And also, if you are, for example, visiting the cinema places, so you'll have a strong interest to entertainment and cinema, but you also get interest to the eating drinking, which will show in your profiles, even though you'll never visited them. And again, if you look at the pattern distribution of distribution of the same places, jumping. So you can see here that eating, drinking, in this case, will be much stronger than, for example, in this case, because all eating places you visit, they are clumped together. So what we can do also with our algorithm, we can estimate how different interests by broadness can be look like. For example, if you have a broad interest and look at the shopping, for example, high street fashion shopping, so you'll see that if you go further within the range, so you won't change the amount of people with the shopping interest, which tells that the shopping is kind of a broad range interest. If you look at a more niche interest, like a nightlife, for example, a Calvin Klein audience, you'll see a small proportion of people will have a short range, but then when we try to look further and going from local to global, so you'll increase this range. And again, what we can also do with our algorithm, when we look at the profiles, we can really select the profiles with the strongest interest from this distribution. So really concentrate our efforts on the more receptive audience. Just to give you one use case before I finish about what we do with data when we can aggregate this. So, for example, if you want to find out the target audience which drink after work and young audience, so what we'll do. So we'll look at the affinities of users to drinking location after work, and we'll be looking where these users with this affinity spend the time during the day. So this is how the results will look like with the hotspots of where we can find the target audience outside of eating drinking hours. So this is a small demo. We have a polygon, 500 by 400 polygons in London, and this demo for out-of-home campaign which we are currently planning. So this is a kind of a planning tool for this campaign. So if you concentrate, for example, on this square, and if you want to find out what is the audience in this square in terms of the eating, drinking, this is this affinity score, general affinity score of the audience. So you can see if during the whole day we have kind of 15 points, but then if you break down into time intervals, so you can see during the working hours it's 15, it's more or less non-changed, but then you can go further and try to understand the affinity of this place to eating, drinking during the out of work hours, you can see that the intensity is changed and the affinity grows. And you can also look at the nighttime, for example, the people who live in this area and what is the affinity of these users toward eating, drinking places. So then based on this map, you can clearly identify the locations where you can find the people with the right affinity, even though where there's no, if for example, eating and drinking places whatsoever, like this square, for example, there's no eating, drinking, but the concentration of eaters and drinkers, they're really, really high. So the expected outcome of our technology is that we can identify absolutely non-obvious places where the desired audiences can spend their time. We can increase the foot traffic and create the uplifts for the brands when they target them using different targeting methods. And moreover, we make everybody happy because the customers won't be targeted, bombarded by non-relevant messages because simply they are somewhere close and without any connection to the place. Just to give one example, before we finish, we just recently ran a campaign for Jameson's Whiskey Lovers. And one of the really unexpected results, which we didn't expect at all. So we found a few location spots on the Oxford campus where there are no pubs or bars whatsoever, even within miles. But actually, these spots show that the people in this area have affinity to Jameson's bars generally. So, coming back to the title, how this is related to the Minority Report in 1 and 2. Sorry, this is the wrong one. So the Minority Report 1 is, as you remember, I'm sure you saw this film, that when being walking around the environment, so we'll be always exposed to something which is relevant to our behavioral traits. But I mean, this is already happening, and this is especially, I mean, what kind of maps I just showed you, they could be adjusted in real time, and will be really shown something which reflects your behavioral traits. But what is Minority Report 2? Is with all this knowledge about how our brain transforms the environmental data into the brain activity, which could really help us not just to match the offers, for example, recommendations to what we are, but to change it. And again, this is about to happen as well. Like, for example, the application of changing consumer behavior and like sponsored journeys, like for example, Uber Zero, if you know, they force you to change your behavior when there is some offer in place. So this is what we will be looking next, Minority Report 2, and hopefully we will be able to talk about this very soon. Thank you very much, and I'll be happy to answer all the questions now or later on. So I'm about until the end. Yeah. Thank you.
Yeah. Thank you, Alexei. I think it's a nice blend between biology and location intelligence. Really cool. Can hardly believe there are no questions, so who has one? Everybody, biology, A-graders here, so everybody understands it?
Thank you very much for this interesting talk. It reminds me to some classes at our university. We're talking about geographic information science and spatial thinking, but I was wondering how you make business out of that, so who would be typical customers who would pay for whatever you showed us right now?
Yeah. Thank you very much for the question. Our main customers currently is in advertising and marketing. So out-of-home advertising, for example, they do planning based on our insight on the place. So if, for example, they want to find eating drinkers during the day, they can use place posters based on our heat maps. And also mobile advertising, they can target consumers based on our profiles. So whenever they saw somebody on the system, they open mobile application and then they connect to our platform with the profiles and then say that this user has got interest to luxury location and interest to shoe shopping, so that they can send the relevant message in real time. I mean, they do already. I mean, yeah, it's working. as we speak. Yeah.
Another question? Okay. Anyone else? Okay. Thanks again, Alexei.
Thank you very much.
Our next talk comes from Ubi Labs, and yeah, just some hardware presentation changes here.
Give me a second for one Mac.
You have also two. Stage is yours.
All right. It's a bit bright, but okay. So I'm quite happy to be here again. It's my third time on stage of the Wherecamp. I haven't been here for the first year, but since the second year, I've been here all the times, and it's super amazing to see what happens and how this whole theme evolved. And I would like to show you something different today. So we heard a lot of things and topics about like how we work with big data and improving data and stuff like that. And I would like to step back a bit and show you something that we did and that's more like, or should remember us of the beauty of our world. So this is sometimes a thing that we forget doing our work. So we work a lot with data, we are focusing on algorithms, but in the end it's all about like our environment, our earth that we are in, and we created a project that should make it possible for all people around to like experience the beauty of the nature. And this is what I want to talk about. The project is called EarthView. And maybe to introduce myself, I'm Martin Klepper. I usually give topics on really hardcore themes, so it's more like hardcore programming, like getting spinning globes done in 1K of JavaScript, or creating visual interactive visualizations for big data, for like moving objects of millions of cars or something like this, all in a browser. And we do this at a company called Ubi Labs. I'm one of the founders. We have some more people around here. We are in Hamburg, and we are focusing on all kind of map-related stuff. So we're more an agency. We are not like building our own products. We started to, but usually we work for clients and all kind of clients. And one of our biggest clients is Google. So we are one of the interactive agency partners for Google. We do quite a lot for them. We do all kind of marketing-related stuff. We also like develop some things that they are using on the website, not on the API, but more like on the public-facing sites. And at one time, one of the Google Earth project manager came to us and said, okay, we have this tool that's super cool and super fancy. All people love this kind of interaction that they have. But what I like most of Earth is that somehow like art, what you see. So when you open this up, it's not about like browsing the streets, it's more like looking at places and see how beautiful these things are. And we sit together and created a project called EarthView. And the first thing that we did is redesigning the Google Earth download site, so the site where you go to download the application. And not sure if you've been there since like 2 years, it's changed. But what you see first is this kind of image. And so you have like full size image of something more abstract. And after some time, the user interface like fades in on top. So this is quite fast, and it's a thing that we use to give it more like the representation that it should deserve. And what we also wanted to do is like to switch and like show different pictures in the background. So in this case, you could open up, see this sea lines, or if you do a reload, then you might see the strange patterns. And this was something new, and people really liked it. And we collected about like 100 locations, and they were all like changing in the background once you reload the page. And at the time when we are done with the project, there was this Chromecast coming out. So this thing that you put on the TV, and you have like, you can connect your own devices and like screen your own things. But it was kind of boring mode. When you open it up, you just saw some text and graphics. And the team asked us from the Chromecast, can you provide these images? So we worked with them to create it like an interactive version where you have some things going on in the background, and you can use your mobile phone and see, okay, what is this? So it gives you an explanation on your second device to say, for example, oh, this is in Chicago, United States, or you go somewhere else and you see something from Peru. And once you click in there, the map opens and you have like the location on your mobile that you can explore. Yeah, so the thing then, what happened is, they asked us, can we collect the 1,000 or maybe 2,000 most striking and enigmatic landscapes available in Google Earth? So we didn't want to stop with this like just 100 locations, we wanted to scale it up a bit. In the end, I think we collected more than 5,000 locations, and all like choosing them by hand. So we're framing all the location by hand, we're searching, using a special tool that I'm going to show in a second. So, but to like route this kind of beautiness to the users, we thought, okay, how can we make it possible for like everyday user to see this kind of nice images? And what we came up with was this. So this was like, whenever you open up a new page in your browser, you see a blank page. So there's nothing, and I think there's this like Google search in there or some like hot links, but we thought, okay, this is not nice, so it's not beautiful. And we created a Chrome extension. It's called the EarthView extension. And what it does is like every time you open a tab, you see a new beautiful image. And we collected like thousands of them. And it's loading super fast, so it's reloading stuff in the background, so there's no break in between. And every time you open a tab, you see landscapes. You see like deserts and strange looking things that almost look like art. And you just continue to do this over the day, and it changes every time you do this. And what happens after some time is that you end up with something like this. So this was one of the feedbacks that we get. Okay, this is so cool. I constantly open new tabs instead of doing what I want to do. And this was also the kind of reviews that we got. So congratulations on making the most distraction Chrome extension ever. Now, when I open up a tab, 50% of the time I forget why I open it up, and I'm spending the next 10 minutes on Google Maps. So, but this was a really great feedback, and there were more like lyric feedbacks like this. This takes your breath away in the middle of whatever you thought you were doing. It's easy to get lost in a thought, and you keep remembering where you live, you exist, when you mindedly open a browser tab. It's not distracting, it's life restoring. So this was like the kind of feedback that we got. It was really like, I think everyone gives 5 stars, except of those who don't know how to deinstall the extension. So it's kind of hidden in there, but yeah, that's it. So this was like the second step that we did. So first step was designing a new Google Earth page, download page, then we did the Chrome extension. And we thought, okay, this is only bound to the Chrome users, so we want to have this like available for everyone. And we set up a website called earthviewwithgoogle.com, or there's a shortcut, g.co/ev. And when you open up this page, you see just something simple. So you always have a changing background, a tiny short text, nothing more, an explore button. And once you hit it, you just see the pictures. And you can use your like arrow keys to go to the next pictures. And we also get quite good feedback, because what we try to do here is like getting away all kind of user interface from the user. So we didn't want to show extra things like extra menus on the first place. Only when you move the mouse, you see something, or when you have a specific region, then you get some more contextual user interfaces. Like this, for example, the get link, and I'm going to zoom in here a bit because we also try to make it look really nice, so it's like a pearl thing that's animated from top to down. Or the globe in the bottom right was like spinning. It looks like flat thing, but actually it's like 3D. And if you open this in the browser extension, you also have the way to like go back in time. So it happened that you see something cool, then you go to a new page and thought, oh, what was this? So I want to go back. So I saw this other thing. I go back and see this lake. I say in a button, it's somewhere in Israel, so I want to explore it a bit more, so I can hit the globe and go to the Google Maps version where I can like pan around and see it more in the context. This is something that doesn't look like, but this was the tool we used, or that we built. So this was not built for beauty, it was more for exploring things. So you see there were a lot of people in there currently. It's a real-time application with shared context, and you can use your browser keyboard, for example, 1, 2, 3 to zoom in and zoom out. You can give ratings, all done with the keyboard. And just to show you how this works, so when you press the R key, it goes to a random location, and then you can use your keyboard to zoom in by the factor of 1, 2, or 3, or 4. And you move your mouse, instead of panning, you're more like zooming into this place. So I think it's a bit hard to see when you're not using it, but it was a way to explore things on a map super quickly. And in the end, we end up with, I would say like 5,000 locations. We sorted out a lot. Maybe increase the contrast a bit, so it was like all over the world we found something. We focused on different sections and try to make it more like global thing. Another thing that we had to do is what we heard before. Some of the images looked a bit cloudy, so we touched every image in 2 ways. So first of all, we increased the contrast. We changed the white balance, which is maybe more obvious here. So this is a picture from a city. If you increase the contrast, it looks like this, but it's a bit too blue, so we corrected this and make it more like natural. And we did this like for all images. We also created a book for the 10-year Google Maps birthday, which was in February, and gave it out to like many people who were involved in this project. And it started to like grow over what we thought. So what happened, for example, is that the Google marketing team used it on every place where they could. They put it on Instagram, and this is how they got really a lot of followers. So they didn't use Instagram before, but because they didn't have something special for Instagram. So what they did is, instead of posting photos of the surrounding, they post photos like a photograph from the world. So what we were doing is more like being a photograph, but instead of walking around, we use the satellite images and use our framing for this kind of shots. Of course, Google Plus, on Facebook, and of Twitter. And this is another project that was related here too. So once we finished with that, the Google Data Arts team came to us and said, okay, this is so cool, and we have something that you might be interested in. They are going to set up the world's biggest screen on a Times Square, which has a resolution of, I don't know, really high. So it's a full block display, and it's also going around the corner, and you can put stuff there in an animated way. And to give you an experience, so this is what we did, and we were there last year in December, and it was super high resolution, animated tilting, and you could always like open up your phone, go to a website, and see where this location is. And this was like really stunning, because like everyone was going around to see that. The resolution was, I would say, like 75,000 megapixels, so quite a lot. We used some tools to get the data mostly from Digital Globe. Yeah. So it was kind of cool project. And another thing that we did is for the birthday of Google Earth, they changed the captures. So capture is something that you have to type in some words that you see on the screen, to make it make the browser know that you're a human. And we changed the backgrounds, or Google changed the backgrounds for the captchas by just displaying this kind of images. And you couldn't hit the Explorer in Google Maps button to see where this thing was. And I think it was like 170 million impressions per day for only this location, and the conversion rate for the people that actually clicked on that was like 10 times higher than the usual one. Yeah. I'm not sure if you have a new Nexus phone, but they also decided to make this like a branding thing for their devices. So they are now using satellite imagery on all kind of devices. So it's on the Chromecast, it's on the tablet now, it's a default background for the new Nexus 5X and Nexus 6P. So it's a kind of thing where Google understands this is something that people like, it's a real thing, it's not an abstract pattern in the background, it's something that connects them, and it's also visually appealing and nice to have, and it like crosses all over all like boundaries of the product side. Yeah, and maybe to sum up, this is something that I would state. So it's not about us that we are the super cool photographers and artists. It's more that Earth is still the greatest artist. So this is also like a picture that we found on a satellite image, and it looks like someone draw an abstract painting on a canvas, and it was really nice to find all this kind of like really good looking pictures. And to finish up, I would simply show you the top 10, in my opinion. These are more like abstract ways of seeing the world. We like try to focus on also urban areas, on like coast and sea, on deserts, like on wood, and we try to make it really a wide range. And this is like my personal collection, which doesn't include that many cities, but it gives you a kind of like impression of what we did. So it's beautiful. It's just this red looking thing that I think it's based on some iron thing that it makes it more red. Another really cool things where you can see the waves like shaping a kind of pattern. This is something that we found a lot. So it's not only that Earth built something, it's also that the humans are like interacting with the surrounding. And these are all like, I'm not sure if these crop circles, but I think it's more like more watering things. So they put something in the middle and try to water in a circular surrounding. Another thing that we found this was too fast. So that one is in Australia, where they put something through the desert that's close to the sea. Other strange looking things. And in my opinion, it's super beautiful to see this. You also have this like crossing things where you have this more abstract patterns and really geometric things going on. And in some ways, for example, this was all north and up, so we didn't have to straighten the image. It was there. Yeah. I think there are like 3 left. Another one where you see is something in the desert in the center and like ways going to there. And more fractal things that shapes more mathematic kind of structures. And one of the most beautiful things in the Great Prismatic Springs in one of the national parks in the US, which has this kind of strange colors because of bacteria that live inside. So really cool. And this is also something that you see a lot. So like salines, I think it's called, where you like get the salt out of it, and they are doing strange reflections with the light and like providing this kind of these colors. Yeah, and that's it from my side. I would say thank you. Thanks for listening. We have a website, ubelabs.net. It's currently in progress, so next week there should be a new one. Don't look at it now, but in 2 hours. And yeah, thanks for having me.
Yeah. Thanks, Martin. Really impressive. Yeah, obviously a question from Digital Globe, yeah?
If there was a contest for the best images, you won it by miles today. Well done. I was wondering, you said that the people select images on a manual job. Have you thought of exploring an automated algorithm using, I don't know, spectral parameters, color balancing, and other things?
Yeah, good question. We thought about scaling this. Yeah, and I would say there are two ways of doing this. So one thought that we have is like making this tool more open, or like creating something like a community where you can log in and like let other people explore the planet and just say, okay, this is something really nice, I want to send it in, and people doing the reviews for it. And the other one would be to say, okay, let's find a kind of algorithm that does it. And we provided like these images to the team that does this this pattern recognition, and they try to put it into their systems to like scan the planet for it. I think there was no success so far. I think it's not enough data that we have, but we could do this. And I would say it's quite hard of work. If you see the coverage of that on a really low level, I would say like 1% or less than 1%, maybe 0.1% really come up with a nice image. So it's still a lot of manual work to select all these images. We also had like a lot of problems with different image sources that we have to filter out. You said you're working on that, which is super cool to hear. So creating this nice looking mosaics, because I would say like at least 50% of the images we couldn't use because of the quality, or like mosaic things or strange looking colors. Yeah. But I hope this will be possible. But I would also say there always has to be a human eye to look at this. It's also like different team members are creating different results, because I think you have to learn this kind of things, like learn how to look at the thing in a visual way. Yeah.
Okay. Any other
Some more
questions?
questions?
Yeah.
I think
Okay.
we're quite late. I made it exactly in time, but
No, thanks again for your talk, right? I think we'll make a shorter coffee break if possible, so maybe 5 to 10 minutes, because yeah, we're running already 20 minutes late. The next 3 speakers, I would please to come here and give your presentation so that we're already prepared. Okay, thanks.